Working with properties of exponents. As a review, the bottom part is called the base, and the exponent is what the base is raised to. And what it states is how many times that base is being multiplied to itself. Now, when we have properties of exponents, we're going to be working with a couple different things. Just like a coefficient in front of a variable, if it's 1, we don't see it. The exponent works the same way. If we have a base, we have an exponent of 1, whether it's a variable or a number. So every base has an exponent of 1, but the 1 we will not always see. So in this case, I have a base of 5, and what it means is I have an exponent of 1 with that base. Or if I want to simplify and I have something raised to the 1 power, well, then we just simply have what is there, which is the xy. The next property is the 0 property. Anything raised to the 0 power equals 1. So anything raised to the 0 power equals 1. If we have 5 to the 0 power, it means that it equals 1. If we have a quantity raised to the 0 power, it equals 1. But be careful here, because when you have a variable raised to the 0 power and it's being multiplied to something else, the only thing that equals 1 is the variable with the 0 power. So in this case, I have x to the 0 power y squared. So it means that I have 1 times y squared, which means my answer is y squared. So it's only the thing with the 0 power that equals 1, and if it's attached to another variable, we have 1 times that. Pause and try. So again, be careful here. It's x to the 0 power that equals 1, and I have 2 times 1, which equals 2. Pause and try. In this case, the whole quantity is raised to the 0 power, so this is equal to 1. So the next property is the multiplication property. And what it states is, if you are multiplying like bases together, in order to simplify, you add the exponents. So when you multiply like bases together, to simplify, you add their exponents. Here's an example. I have 2 to the 4th power times 3 to the 3rd power. They are like bases. The base is 2. To simplify here, I would need to add the exponents, and I end up with 2 to the 7th power. Be very careful with this, because when it's numbers and the bases are numbers, we have a tendency to want to multiply the numbers together and have 4 to the 7th power, but that's incorrect, because order of operations state we have to do the exponents before multiplication. So in this case, the property of exponents would apply, where I would take the like base and add the exponents. And here we see that we have z to the 6th times z, and remember that z really has an exponent of 1, so when I multiply this together or simplify, I end up with z to the 7th power. Pause and try. So in this case, you see that we get 3 to the 5th power. Pause and try. So in this case, remember that has an exponent of 1, so we end up having x to the 9th power. So now this is still the multiplication property, but now we have multiple things going on. I want you to be very careful, because when we do the multiplication property of exponents, when there's numbers being multiplied together, you need to multiply the numbers. So the numbers get multiplied together, and the like bases with the powers get added together. So whenever we're doing multiplication, numbers are numbers, numbers get multiplied together. So 3 times 7 is 21, and then the like base of k, I add the exponents and I get k to the 8th. So be careful that you don't do 3 plus 7, it's multiplication, 3 times 7, which is 21. This has multiple variables and numbers. So again, you want to make sure that you're putting the like bases together. We have 12 times 2, it's multiplication, so we end up with 24. And then we have x squared times the x, so you're adding the exponents, we get x to the third. And then y to the third, y squared, we add the exponents and we end up with y to the fifth. Pause and try. So here we get a negative 2 times 4. A negative 2 times 4 is a negative 8, and we end up with x to the 6th power. Pause and try. So remember to always bring the number in front. So it's really 1 times 3, which is 3, and then we get x to the 10th, y to the 8th. So now we're going to do the division property. The multiplication property is addition, we add the exponents. The division property, we subtract the exponents. Now the thing with division is you always want to see where the higher exponent is. If the larger exponent's on top, you're going to subtract and it's going to stay on top. If the larger exponent's on the bottom, you're going to subtract and it's going to stay on the bottom. And if there's nothing left up top, you need to put that 1 there, because then you end up with a fraction. So here's an example here. We have x to the 5th divided by x to the 3rd. The higher exponent's on top, so I'm going to subtract the 5 from the 3, and I'm going to be left with x squared. This next example, you see that we have the higher exponent on the bottom. So I'm going to subtract, because I don't want a negative exponent, so I'm going to subtract from the bottom. So I'm going to have y to the 8th minus 5, but I need that 1 up top because I need something up top to indicate that we're going to end up with a fraction as an answer. So we end up with y 1 over y to the 3rd. So now this kind of gives us why we get something to the 0 power equals 1. So in this case, we see z to the 5th over the z to the 5th. This is that one property of fractions. When you have the same thing over the same thing, it equals 1. And this division property shows us that we would have z to the 5th power minus 5 would give us z to the 0 power, and anything to the 0 power would equal 1. Pause and try. So we end up with x to the 4th power. Pause and try. We end up with 1 over z to the 6th power. Pause and try. So the like bases here are numbers, but we still do the same thing. We're subtracting the exponents, the higher exponents on top, so we end up with simply 15 as our solution. So now this is a multiple step property of exponents, and it's working with division. Now whenever you see something like this, I like to break it into 3 separate problems, working with like bases. And I always like to draw my line and do step by step. So I'm just looking at the first piece, which is a fraction. A fraction needs to be reduced. You need to reduce any fractions. So 5/15 would reduce to 1/3. So reduce the fractions. You're not subtracting the numbers, you're reducing the fraction. The next piece, I see that the higher exponent's on the bottom, so I'm going to subtract and I'm going to leave it on the bottom. And then I go to the last piece and I see the higher exponent's on top, so I'm going to subtract and I'm going to leave it on top. And remember that y really has an exponent of 1, so we end up having 7 minus 1, and that's where the y to the 6 comes from. Now be careful here, because we don't want to have that 1 in front of the y, because we normally don't see a coefficient of 1. So your final answer, you want to eliminate the 1 and have y to the 6th all over 3 times x to the 3rd. Pause and try. Again, I start by drawing my line and working piece by piece. 3 over 9 reduces to 1/3. And then I see the higher exponent for x is on top, so I'm going to subtract and leave it on top. So 3 minus 2 is 1, and you don't want to have an exponent of 1. And then the higher exponent's on the bottom for the y. I subtract 1 from 3, I get 2. And my final answer, I want to get rid of the coefficient of 1 in front of x, and you're left with x over 3y squared. Pause and try. So in this case, I'm drawing my line and I'm working with the numbers first. 8 divided by 2 is 4, so it's going to be on top. And then I see the x to the 5th over x to the 4th. Higher exponents on top. I'm going to subtract and leave it on top. And then y to the 0 power equals 1. And we're multiplying, so 1 times anything is what I get. So I end up with just simply 4x. So my answer here is just 4x. I just like to draw the line to put the pieces where they belong. If nothing's left on the bottom, then I end up with a whole number.